Welcome to the massive open online course in the subject computer science. The topic is operating systems. Today it is a case study on the Linux system. The syllabus has two case studies, Windows and Linux system. There are so many concepts that go behind making operating systems. It began with a very small piece of code functioning as a resident monitor to make sure that some usage of the devices which will be common to many user programs is taken care by the resident monitor. Gradually there are 18 to 20 full functionalities that began to be demanded by the users. Today the operating system is very bulky, it occupies gigabytes, petabytes of memory, but then it offers so many functionalities that a user who is writing an application program can take advantage of very high quality code that is already available in the operating system. The operating system that paved way for such a method by any user is the Linux system. Till today, Linux remains the very first operating system that showed us the way of using the high quality code that is already developed in the system and make an application program at a quick pace. Very quickly we can develop an application program. The idea of the file system, the idea of having such a provision of a virtual memory, all these things we trace back to the Linux system. However, before the Linux operating system came into being, and that was what was called Multix. I am switching to the internet mode, and in this we are seeing the Multix operating system, which was called Multiplexed Information and Computing Service. What we have done is, in the Multiplexed Information Computing Service, it is a mainframe time sharing operating system. It is very rare that between 1963 and 69, that is nearly 6 to 7 years, there was a wonderful collaboration between the Massachusetts Institute of Technology, General Electric and Bell Labs. All three have been giants. Some of the best brains in the area of systems got together for nearly 6 to 7 years to make what is called Multix. The design was nice, however, it was declared a failure. In 69, Bell Labs broke out of Multix. Multix taught us some very nice ideas which later on were useful in many other operating systems, and as we see, we switch to the next article, Multix, which is on the Wikipedia. Takes little time, but Multix was a ringed operating system which is now Multiplexed Information Computing Service. It is an influential early time sharing operating system based on the concept of a single level memory. It is a very simple idea where we have one level of memory and we want to do multitasking. Essentially, it traces back to the early days of doing multi-programming. We found that multi-programming has a serious limitation on the number of users who can simultaneously do multitasking on the same set of resources. We quickly moved over to a virtual memory system that remains the roaring success of UNIX operating system, which was named UNIX more as a pun on Multix. Multix has a great influence on Linux, Mac OS, and it has indirectly influenced the Windows NT. The initial planning and development for Multix started in 1964, and we had the pleasure of going through plenty of documentation on Multix project, which was led by MIT. It was called Project Mac with Fernando Corbato along with General Electric and Bell Labs. In 69, Bell Labs move out of it, and the rest of the story is the history of UNIX. It is necessary to understand that the basic design of Linux is stemming from an idea called open source. It is a topic in the syllabus, and we have to do that topic first before understanding what is the basic motivation for creating Linux? Linux is one of the most successful open source endeavor in the history of computing. There is so much of literature available now. The entire Linux code is available. It is well documented with lot of hypertext. So what we need to understand first is the idea of Multix with a single level memory was a failure. However, Bell Labs, which moved out of Multix project in 1969, went its own way to develop a multi-level memory, and using this multi-level memory they have created what is called a kernel. This kernel was distributed free to students in many academic institutions because Bell Labs had license to sell only communication products, no systems, no software, nothing related to computing. Those 2 years was so fascinating. Many students across the higher learning institutions all over the world and specifically in the US started working on this kernel, which is a very small size kernel which was nicely built by Ken Thompson, Brian Kernighan and Dennis Ritchie. UNIX was written in C, the kernel was written in C. When this piece of software called kernel reached the academic institutions and the students began to find it very interesting to write up code for their own work, it became a fantastic operating system by 1971. That decade began with a fantastic solution to software development, that is, use a kernel, use a file system, use multi-layer memories, use virtual memory, and you can build your own set of functions on the operating system. All of them will be put together and we have UNIX. 71 it was the first year of that decade which saw the commercialization of UNIX, and what was very attractive for the industry was by the time the students graduated, they were very familiar with how this operating system called UNIX is working. And as I said in the beginning, it is the first operating system that taught us that if there is a high quality code which is already developed in the system, an application programmer can make use of that code, develop the application with a better quality at a faster pace. This is the first lesson which the UNIX programmers have learnt, and the applications that are being developed had many things to do. All students put together virtually everything which they wanted the machine to do: computers, communications, anything that you want to do. Talk about databases, talk about networking. So many functionalities were all built as rudimentary commands first. UNIX did not have a great user interface. It only had a command line interface. Most of the UNIX commands were very cryptic. They were not easily understood. However, the designers of the UNIX gave so many options to the commands that they can virtually do anything that they want the system to do, the computer to do, the network to do, whatever they want to do. Any application that they want to develop has some kind of a support from the operating system. That is the reason why UNIX succeeded. It is a phenomenal success of UNIX. However, it was still built only through the Bell Laboratories and it was still maintained, sold. The story of UNIX has taken such a wonderful journey in the next 2 to 2.5 decades that gradually it has become a flagship for the success of operating system of that size, and something which many people wanted to emulate. It has influenced the design of so many operating systems that we don't mind talking about UNIX anytime. We can talk about UNIX, we can talk about the way it has supported the design and development of system software which is so advanced, and it supports such a wide range of applications and user has the control, except that it was a command line interface. However, this particular case study is a Linux case study. Linux came out of open source. That is, people all over the world who were volunteers started working on a very simple piece of hardware. Gradually, purely in a voluntary manner, millions of lines of code was developed. lakhs of people all over the world. We don't even know whether there is an affiliation to the university, to a given university or not. They were all there, but the best part of it is the person who initiated the development of Linux, that is Linus Torvalds, who is from Finland. He has gotten back the entire code completely with due acknowledgements, which is a great symbol in the world of open source. The person who has started it went through the exercise, sat through very patiently how the open source code is evolving, what are all the errors, lakhs of volunteers, million lines of code, and finally all people who are involved with this project attributed it with due regards and acknowledgements to Linus Torvalds. Now, what are these design principles that made it so fascinating? It's a Unix operating system from which Linux is derived. Unix itself was a pun on the failed Multix project. To examine the Linux process model and illustrate how Linux schedules, processes, provides interprocess communication, we also look at the memory management in Linux to explore how Linux implements file systems and manages I/O systems. So, we will move over to what is called the Linux documentation. We will switch to this. We will look at the Linux as a modern free operating system which looks like Unix, but the best way to describe it is based on Unix standards. It was first developed as a small but self-contained kernel in 1991, that is 2 full decades after Bell Labs started commercializing Unix by Linus Torvalds, with a major design goal of Unix compatibility, released as open source. There was no point in time when it was supposed to conflict or compete with Unix. It was expected to be compatible. Lots of design ideas have become very obscure in the Unix operating system. It was developed well by the students who were learning the subject of system software. 2 decades it was a runaway success. So many operating systems were influenced. Naturally, there was an inquisitiveness of how Unix itself was developed. And the best way of learning how Unix itself is developed is to go through the entire Linux documentation, which is out here. We can probably access it sometime. It's a nice project that you can think of, and we'll have the story of Linux documentation coming in much later. The entire Linux code, source code, is available. There is no more concern as to how system software can be developed, how many services a piece of system software can provide. It's an open book. You can always go to the Linux documentation. It is hyperlinked. You can read every line of code on Linux, and therefore this is a good case study to have it in your subject. Its history has been one of collaboration by many users from all over the world, corresponding almost exclusively over the internet. We have always been having that hunch that in open source things do not succeed right from the scratch. It must have been tried out by some people. Open source gives you a real chance of improving everything, including the process of development. This is a hunch that we have been having. It's very difficult to find out how open source projects can emanate from nowhere. The very first idea, usually open source, is to look at something. It had difficulties, it didn't start off, it didn't take off, it was declared failure. From there we take up and develop open source. Here Linux was clearly to understand how Unix gets developed, be compatible with the Unix standards, but it's an open source. There is no hidden line in that. You can get every line, every detail of the operating system. Please do make use of the Linux documentation, which is there open. It doesn't cost us much. The core Linux operating system kernel is originally designed. It is not simply copied from the earlier operating system, but Linus Torvalds ensured that the kernel is built from the scratch. It's original. It can run much existing free Unix software. It's compatible with Unix. Linux system has many varying Linux distributions, including the kernel, applications, and management tools. So what we have done with the Linux kernel is that in May 91, the version 1 was released. It had no networking. ran only on Intel compatible processors, and on PC hardware had extremely limited device drive support and supported only the Minix file system. Minix file system was built by Andrew Tannenbaum, and in the Minix operating system it's a very compact file system. This is how the Linux kernel was designed. However, we know that it's nice to learn this design as to understand how the early kernels were developed. It's an object lesson in building kernel based operating systems. Most operating systems today want to borrow this design. There must be a kernel, and around the kernel we build a lot of support systems. This success of a design is very rare to find in the world of software. The idea which we wanted to do some years later, 3 years later, Linux 1.0 included features which began to network using TCP/IP. So, what was very native to Unix? Unix has a built-in communication protocol, that is Unix to Unix copy. Every Unix box could talk to every other Unix box, UUCP. However, Linux designers moved over to the then well established ISO OSI network protocols, International Standards Organization Open Systems Interconnect Network protocols, and what was happening was therefore a seamless blending of the boxes that run Linux, Unix and any other brand of the machine, because the protocol stack being used by all these boxes, all these pieces of software, all the operating systems remains true to the ISO OSI reference model. Immediately all Linux operating systems got connected to everything. The best part of it is we now have plenty of devices that can be located. There was a point in time when every new device that you want to connect to the system will need a device driver that must be located on the system, launched. The device should be detected. Even today it happens when you put the dongle, it takes some time, it is recognizing the dongle, it takes a few minutes. All these are very common considerations which we have been having all along. However, what we need to understand is it's difficult to track it ourselves. See, look at this Linux documentation. I do remember that this particular exercise was initiated by me, but the operating system should ideally tell me, now you got the Linux documentation project online. So, there is a man pages, the manual pages. It is so nice to see that we have welcome to Linux kernels documentation, there is a kernel.org. Every line of code, every semicolon, every variable is fully documented at kernel.org. It is a path breaking exercise in open source world, and it has been a precedence for many open source software to come, which includes your Apache web server. And you see how nicely it is structured. Lot of volunteers have gone into writing up these pieces of code. How is the kernel developed? Code, sparse code, introduction, spins, build. You keep seeing this working with the kernel development community, the Linux kernel users and administrators guide. Everything that you want to know about Linux today is available on the net, and there is no reason to believe that it is something which we cannot use also, provided we give that due regard to the people who made it happen. There are certain simple copyright rules based on which you will have to see which part of the code can be used in your application. Straight away you can use it. It supports a wide range of devices. Today device driver is no more a serious concern. You simply plug in the name of the device, the type of the device. Somewhere in the internet there is a device driver, there is a piece of software that alerts saying that yes, this device can be accessed to this device driver. Just download it onto the system, activate the device driver, and you are up and running. Writing up device drivers today is no more such a serious challenge as it was nearly 3 decades back. It was very lucrative. People were charging a lot to write a device driver, otherwise how will you use the device? Today we are talking about Internet of Things. You can have a thing anywhere and you can write a simple recognizer of that particular thing, it works. You can detect it online, you can go ahead and use those device drivers. It's an enhanced file system, support for small computer systems interface SCSI controllers. Now, most of these controllers which were controlling lot of devices, high performance disk access, quickly moved over to SCSI, and today it is universal serial bus, all are USB ports. So, please understand that Linux has brought in together a device independence which was never experienced in any other operating system. Any device can be connected to any other device. We have any port, you just have to tell that this is the port, it works. Of course, it happened after 2 decades of UNIX became commercial. 71 UNIX became commercial. Linux went ahead with the 1991 condition, which is like this. The 1991 had no networking, ran only 8386 compatible. By that time, we were already talking about Pentiums coming, 586 coming. However, it's a very rudimentary version of Intel processors, PC hardware, extremely limited device driver support, and supported only the Minix file system. Linux 1.0 included those new features: BSD compatible socket interface for networking programming, enhanced file system, extra hardware support. Version 1.295 was final PC only Linux kernels. Kernels with odd version numbers are development kernels. Kernels with even numbers are production kernels. It reminds me of many good old days where we were very conscious about whether the kernel number is odd or even. If it is odd, it is a development kernel. If it is even, it is a production kernel. The open source world was very active. Every day you can come up with a new version. That's the secret of success of open source. Frequent releases, frequent versioning, version control. It has been a very fascinating effort by volunteers all over the world. Lakhs and lakhs of volunteers have contributed to a very high quality code, production quality code, that many of the other organizations, software development organizations, were willing to learn from. That's a quality of code development which was so fantastic. The main system libraries were started by the GNU project. The GNU is not Unix. This is by the Open Source Foundation, and what they have done is, if it is simply going off control, Free Software Foundation, that's FSF GNU project, GNU is not Unix. MIT's X window gave us the first best interface. Berkeley's BSD operating system was so much focused on networking, it's a super special exercise for networking. Berkeley standard distribution operating system, all these are varieties of Linux. There are so many flavors of Unix, so many flavors of Linux, but Linux taught us the way of working through so many commercial flavors of Unix. Virtually, there was a need for Unix unification. In 2 decades, the commercial world of Unix saw so many ports of Unix that no 2 Unix boxes were willing to talk to each other, which was defeating the original goal of Unix, which was released by Bell Labs in 71. So, the Unix unification project, the Unix standardization project, now all these things really got cemented because of the roaring success of Linux in 91 to 95. The main systems libraries were started. Linux network administrating tools were so wonderfully developed by Berkeley Standard Distribution Code, and Berkeley Standard Distribution was becoming available to us at a very throwaway price. The source code will come. File system hierarchy standard. Linux distributions standard precompiled sets of packages or distributions include the basic Linux system, system installation and management utilities, and ready to install packages of common Unix tools. This is a fantastic feature. We don't need to get an expert to do that. If it is a common Unix tool, it is ready to install, just plug and play. This was the secret of what we call the open systems interconnect. You don't have to run around to learn a lot about all the pieces of hardware. The port speaks for itself. It tells you that this is how you should connect, and see how nicely it is connecting to the internet. The early distributions, which were slightly more popular, they were allowed to charge for the packaging charges. Red Hat became very popular. Debian is another Unix which became very popular. The entire South Africa, for example, went to a version called Ubuntu. The entire South African country was using Ubuntu as a Linux operating system. The Canonical and SUSE projects, the RPM package file format permits compatibility amongst various distributions. It's just a package that tells how we can go across from one particular Linux flavor to other particular Linux flavor. There are some licensing concerns. Linux is definitely what is called a leader in free and liber software movement. The free is not, as the Free Software Foundation defined, is not like a free cup of coffee. You are free to use it, but then please follow certain guidelines. You can feel free, it is there. If you want to use it, it's fine, you can go ahead and use it. It's not public domain in that not all rights are waived. It is not that everything is waived. Please understand that GNU's General Public License GPL was very valuable. There are certain code pieces which can be hazardous. We have always been wary about anything that comes free. We do not know who will assure the quality, who will stand guarantee for that piece of code that claims that it can do that. We are all not computer science experts. Even the best of the computer science experts find it very difficult to understand a piece of code written by somebody else. It's not at all easy. And if you want to change 10% of the code which is written by somebody else, you better take away the entire code and redo it yourself. That is less expensive, it's much faster. Reading, understanding, and then trying to modify a piece of code written by somebody else is lot more difficult, and it becomes prohibitively expensive at times. Then why should I believe that this piece of code that is just there, that they claim, the people who wrote the code claim that it is doing like this? If you are willing to use it, you use it. This is what is called the free in the field of free software, which we are talking about. Open, free, liber, all these are nice terminology. It's open. That is why we like that term open, because the source code is available. Those of you who have the expertise can go to that Linux documentation project or any other open source which is available. All lines of code are available. Even if it is million lines of code, if you can understand that code, please go ahead and use it. Anyone using Linux or creating their own derivative of Linux may not make the derived product proprietary. It is a responsibility of the Free Software Foundation that made them define this general public license, saying that there are certain pieces of code segments which you must be conscious about. It is just not that the code will come, sit down, and then you will make some tinkering on that code, hope for the best. Certain critical pieces of the code must draw your attention, must draw the attention of the people who want to put it to use in their application. Otherwise, the results can be hazardous. People may not be able to understand that particular code. This is a good idea. It's a nice responsibility undertaken by Richard Stallman and Free Software Foundation. They can sell distributions but must offer the source code too. Any distribution under GPL must also come with the source code. If you give the source code, it is fine. Linux is multi-user, multitasking system with a full set of Unix compatible tools. This particular set of slides have been prepared in a manner where I want to drive home the concept behind Linux and open source rather than the features. Features of Windows are also comparable. In the earlier topic on Windows case study, we have looked at certain features, certain aspects of Windows. More or less, all these operating systems have been traced to those original ideas, original designs in MIT, in IBM, in Bell Labs. Those are all the laboratories that have created some original designs. General Electric was also very famous in the field of software. People who have been doing these exercises, some of the best brains have been put together to make this Multix project happen for 5, 6 to 7 years, but then it didn't really deliver. They came back, the UNIX Bell Labs took some ideas and improvised on it, and they made a pun on the name called Multix, which is such a nice acronym, called it UNIX. Linux is designed to be compliant with because of the single layer memory it became Unix. Linux is designed to be compliant with the relevant POSIX documents. All standards are Unix based standards. You do not have to worry about it. What are the components of a Linux system? System management programs, user processes. User processes are something which are very central. All protection, security, many things are covered in these user processes. User utility programs, Unix utilities were a runaway success. There are so many pieces written across the libraries, all that you have to do is to include them. Unix utilities range from everything that you are thinking of working with a computer to many things which you want to build in future. You can develop application development. So, user utility programs, there are a lot of compilers, system shared libraries, a Linux kernel, loadable kernel modules. Like most Unix implementations, Linux is composed of three main bodies of code. The most important distinction between the kernel and all other components. As we keep seeing, in the case of Unix, what the core design was reflected in was called kernel. It has a simple file subsystem, a simple memory management system, a simple process management system, a simple I/O device management system. So, if all these things are put together, a small size kernel was representing what we call the really core functionality support for any operating system which wants to offer these functionalities: device management, file management, memory management, CPU management, and any other thing that is built around these four functionalities. Out of 18 to 20 functionalities which the users were demanding gradually as operating systems progressed, these four functionalities, namely file, memory, device and the CPU, remain as the core, and the support for these managerial activities performed by an operating system is found in the kernel. The kernel code executes only in the kernel mode and it switches to the user mode. The ideas are more or less the same. We have systems libraries, we have system utilities, we have shells, born again. The next topic will be on the born again shell, script, shell programming. Sections of the kernel code that can be compiled, loaded and unloaded independent of the rest of the kernel. A kernel module may typically implement a device driver. Now, I have been a little deliberate not to touch upon so many aspects of the features of the operating system, but more to talk about the nice ideas that have gone behind making the Linux operating system so nice, so pragmatic. The idea of what is called open source, the release, Linux kernel 4.x, command line parameters, reporting bugs, bisecting a bug. There is so much of documentation online where you can simply go ahead and use it. Now, we have been talking about the kernel address, kernel memory leak detector, anything that you want to do, kernel documents, writing kernel documents, everything that you find that you want to learn from the Linux documentation project is simply available online. And what we have been talking about is Linux code, Linux open source code that is also available online, and it will come. As I keep mentioning, the users demand more and more. If you have internet, now I will start demanding how do I automatically switch from the PowerPoint to the net. I would want an automatic switch when what I have been searching is available. Somehow some message must flash on my screen saying that see, it has already come. The Linux code, everything is available. You can go ahead and use it at a small price for the medium. It will be shipped to your address wherever you want to. Now, all these nice things come with only one conditionality: please do not simply pluck, cut and paste the code. It is more hazardous. Please respect the general public license. Please respect the fact that the code was developed by fantastic programmers who are outside of your ken. You won't even know them. We respect them with due regards. We need to understand what is that piece of code that we want to use. The source code is available, the language is known. Please understand the code that you are using, use it in your application program. In a Ziffy, fantastic application programs can be developed. This is the way in which we have been using this case study of Linux. There are so many nice things. Drivers I have mentioned, drivers can be registered online, recognized, and we have a namespace for a file system hierarchy. It's a wonderful world of open source and open systems, and you can talk about protection levels, interrupts, and many things which are capable of multiprocessing, multi-core, and so many other things which we talk about, and take care of all those things. The case study is positioned not on the features of Linux, but the methodology used for Linux. Thank you very much.